Yes, I represent a company called Observant, which was set up about 15 years ago, and some of you will know the name, the Holmes Court family. One of the sons at the time, he decided to support the family business, set up a stock watering monitoring system. They got big holdings up north, so the system that they designed and put together needed to be pretty robust. And over the years, and many years, and I have an ex-colleague of mine who's going to talk later, on the implementation side, they got something that was really seriously well engineered, kind of the Land Cruiser, I would say Land Cruiser of the game. There's some serious money being put into the engineering of those goods over there. And it's called Observant, which has been recently bought out by an American group, well, American-run group out of India. So there's a substantial amount of funding behind this group, and you'll see some slides later. They have a very large footprint in Australia. Not so much South Australia, originally Melbourne-based, but we travel everywhere. You name a town, I've probably stayed in its motel. What the network comprises of at this stage requires a 3G, or not 3G, but a cellular connection somewhere on the farm. We'll speak a little bit later about satellite options, but satellite options can limit cameras, and cameras, as you'll see later, can be extremely useful. So what you see here is typically just a tank with a sensor in it. That's normally mounted on top of the tank, similar to that. And you can have a camera as well, and you can have multiple other sensors. I'll cover that off shortly. But essentially, a whole bunch of these on your farm. We've got farms 40 up towards 40, communicating back via a cellular gateway, which goes to our friends Telstra and maybe in the future Optus, because those are the people we have lots of conversations with when things stop working. That gets sent up through this mythical thing called the cloud. Ultimately lands up in a server where I'm sure the Chinese have hacked all our data. No, sorry, it's not real. And then it goes back to your iPad. You can access it through your iPad or your phone or your computer, essentially just with a browser. So there's no specialist software running on this thing. A lot of, and I don't want to denigrate them, but a lot of companies have special software. There isn't any special software in this. We could give you a login now, demo login. You can, as long as you've got the right password, you can go and have a look at data, and we will look at some live data about 120 k's north of here in some pretty dry country. So that's the network. Key points, it needs cellular coverage at least 1 or 2 spots on the farm. And we also have the option of using UHF radios, and there's very little that beats that in the bush. It's the same radio, in fact, identical radio, it's in the back there, that you have in your ute. It's a 5-watt UHF radio. We use 2 channels, which are not voice channels, they're data channels. So if you've ever gone along and by mistake left it on 22 or 23, and you hear dee-dee-dee-dee, that's in fact these things talking. Very short bursts of data, but those are data channels. Right, the next bit are the actual units that are stuck in the field. This is by far the bigger one, and it does a lot more things than I'm actually going to be able to talk about, because we do soil moisture and flow in rivers and turbidity and all sorts of things that can be done if you plug into the right place here. But the key part about this unit is that it's got multiple radio options. So there's an option of a 900 megahertz radio, which is a free-to-air, there's no license cost. And that would typically be used in our previous area where we did a talk, Narracourt, or in the Hay Plains, where there's a huge project that's being rolled out by Phil. Hundreds and hundreds of farms, but it's flat as a pancake, so you can live with a lower cost, 900 megahertz radio, 9 kilometers, 7 kilometer reach radius, and you can appreciate you can repeat as well, so you can cover a fair amount of ground with that radio at a significant cost reduction. But in a country like this, I wouldn't even bother. Coming from a background overseas of the military with radio, that's why I escaped and came to Australia. I use UHF radio because it just works. If you can talk on your UHF back to the farmstead, there's a good chance this is going to, well, there's an extremely good chance it'll work, but it's the same radio. So this unit can get mounted as it is there with a level sensor directly below feed monitoring tanks, or in the case of open water dams, that can be put on a gantry over the dams. And I'm going to use the word cubby because I've done a lot of work there, not with this equipment, but a lot of experience doing that. And a millimeter change on a 70 hectare thing is a whole bucket load of water, as you'd appreciate in the news at the moment. It's a self-contained unit. It gets sent out to you in a box. You could install yourself completely. They get configured on the air, as long as you do it in an area where you get cellular coverage. Really simple. There's no ways we could get to the next slide in a couple of years without these things being quite simple to install. And that's not me saying, I'm a Scottish guy and I'm pedantic, and if it wasn't simple, I'd put my hand up. That's the key to this part. It can run in a pump shed. There's areas where you want to turn pumps on and off, and monitor pressures and lines. So that box, you don't take the solar, you don't need solar, because if there's no mains at the thing, you don't care about the pressure because the pumps are not running. So that box is mounted on the shed wall and with a power supply straight up its backside. It'll run off at 12 to 30 volts as well if you chose to use other batteries, which we normally wouldn't. So that's called a C3 field unit. And in fact, abbreviated the FUs, field units. That's what we call them anyway, and sometimes rightly so. There's a baby brother of that unit, which is significantly less expensive. It does not have a radio option. So this is a cellular antenna, which we played quite a big part in making sure it worked well in Australia because we've got weird frequencies here. The 850 Next G, they called it. I arrived in Australia when CDMA was still running hot, and Telstra pulled a pin on CDMA. My first job was employed in a company down in Adelaide to engineer the change from CDMA, which actually worked, and some of you would, not you guys, you're too young, but some of you guys will know the CDMA worked far better than anything else out there. And everyone said, why has my CDMA stopped working? And Telstra brought out a lower frequency version called Next G or 3G, or Next G was its name, ran on the same frequencies as CDMA, and they tried to get the same range. Never quite the same. If you had CDMA phones, you would know 20% less range, but they got pretty close. And I did 7 years of that, integrating Next G, and now they're starting to pull the pin on that, which will be interesting over the next couple of years when the sewage stops pumping in the town, and they don't know why, because the little 3G modem in the box that pumps the sewage decides to not talk anymore. So it's going to be an interesting time. So this unit is also self-contained. You would connect 2 sensors to it, essentially. Really good for areas where you just want to do a level, or you want to do a rain gauge, or you want to do a mixture of, but only up to 2, or a level sensor. And the level sensors used in the Observant system are not pipes and sitting down at the bottom of the tank, submersible sensors, pressure sensors. They're in fact ultrasonic sensors, which makes it very useful, because if you look at them, that's it. You get this box, you put in those bolts, you screw a few Allen keys, you take and make sure it talks first. That's what I always say. Just, it's online. You log into your page, yep, that's my unit. There's a serial number at the bottom. And you take it out. You don't care how big your tank is or how small it is in this case. You bolt it, you drill a 2-inch hole, or small as you can, so you don't get frogs and that falling in there. And you stick it down, you gimbal mount it, because a lot of tanks have got sloped roofs. You face it north, and hopefully you've got signal out there, which you would have checked with your mobile phone. And saying that, as long as you get 0 to 1 bars, flickering. In other words, you can make a call, but it's not going to work well. This will work well. And I'll stake my engineering reputation on that. We've done a lot of work to make sure it works well. In fact, there's a few slides coming up. Telstra show it won't work, and we've got units working. So, and that's a testament to us being kind of involved in the background. So this unit bounces a sound wave off the water, or the ground, or anything, but the water in this case. And it's extremely simple. It'll go up to 15 meters. 15 meters on these? Okay, so you can have an enormous tank if you want to, or a very small tank. In fact, there is a limit. I think it's about 200 or 300 mils. It can't get too close, but that's fine, because normally there'd be a header pipe and outflow pipe in the tank, and that would be sat above it. Simple as you plug this in. We've done enough to know that from drive up, after you've got these assembled in the back of your ute, you drive up, you take your ladder off, you drill a 2-inch hole in the top of the thing, but the tech screws even come with the kit, so just to make sure everything's there. Face it north, or what you think is north, and that's going to be good enough. Bolt it down, stick the bird spikes in here, and don't look at them while that happens, and then drive away. 20 minutes. And there's very few systems out there, and we know, because I've worked for multiple companies before this one, that you can do that. Absolutely not. And that's just because they put a whole bucket load of money into engineering this thing, and that's the truth. The other unit is similar, much more difficult to actually put together, or it takes a bit longer to put together, but that's the same thing. Once it's in that state, you drag it up the tank, drill the same hole, stick it down, and drive away. So those are the 2 field units, or FUs. The coverage of Observant is very significant. This is, although they've got a USA office, Australia by far is the biggest footprint. In fact, this is probably a couple of years old, and if we look at areas here, which definitely wouldn't have come up since Mr. Witten had installed some units, and we'll talk about that, where you've got remote blocks, and you need an early warning system, something's gone wrong. And that's probably the highest value of this, is that, so not that many in South Australia, but I can guarantee if we did an update, which we can't do anymore because there's too many and it takes half an hour to load them, because out of all those blocks, you can appreciate if you drill down some areas, which we know we've done some Department of Ag and Fishery for Queensland, there will be 30 or 40 units just in one block. So if you drill down, you're going to find the whole place is covered in orange. Significant areas. Look at out there, Uluru area, the Pilbara area up there. Obviously a lot of dairy down here, which is usually the smaller units, because you don't have to have long range, and you've got cellular coverage. The Victorians love their coffee and their lattes and their, sorry Phil. And there's another Victorian out there, I saw a number plate and I scratched your comment. Parochial South Australian with a funny accent. SA is the same country, you put an R in front of it. Anyway, so you get an idea that this is a lot of monitoring here. I think the numbers are about 7.5 or 7,300 devices, talking to about half of that in telemetry units. And these are only the telemetry units. So in other words, there might be 2 or 3. In this case, there'll be soil moisture probes, might be 2 or 3 in a row. And then the whole map would look at dog's breakfast, so that's not done. So these are only showing the actual units communicating, because they've got GPS built into them as well, which is interesting. If everyone got one stolen and you could get a fix out of it, you'll find out where it was, as long as you didn't put a cap over the top to block the... I come from a country where they steal your car in a parking lot and then sell it back to you as you drive out in a rental car. It's a nice place, believe me. Okay, these are only words I've got here. So the key points here, if you want to look at a system like this, you've got to find a spot on your farm, hopefully centrally, but it doesn't have to be, where we have cellular coverage. And we'll cover some slides later. We then look at the countryside, and if it's very hilly and there's a lot of trees, areas out of Charters Towers is a good example where we had to do a lot to make it work, where we couldn't even get signals 2 or 3 kilometers. Dense forest, not even forest, it's scrubland, but anyway, it just works out to be. So we would choose a 1 watt radio, 900 meg, and there's no cost to those radios except buying them. There's no license cost or anything, like a lot of people have licensed radio systems in horticulture, and they pay a couple of $100 a year to rent that frequency. It's a UHF frequency. There's no cost to either of these. All we choose in this country, I would expect a lot of UHF would be installed, as we know, because we have some around. Then the next part is there any high spots in the farm? And this is the engineering, this is my real background, so I'm talking about it now. And this is called line of sight, which is just like shining a laser light, and can I see it? And that's a perfect opportunity. If you can actually see it, there's a good chance radio will work. Certainly the 900 meg is like that. If you have a little hill in the road or cow walks in the road, you have issues, not seriously, but whereas UHF here, you can drive behind a hill and you get reasonable comms as long as you're not too far away. So I would just do that. It's robust. You can live through storms, and you have as much trust in it as your UHF. And if you roll your truck and you can get to your UHF and you've got no cellular, that's the same thing. Antenna gain type, I'll talk about repeaters as well, because you can appreciate if we get 20 kilometers on a 5 watt link and we can repeat, there's going to be not many farms that we can't cover, because we can then repeat down the chain. And these are radiuses, so you can, and I'll show you a picture of that, how that's done. But generally we'll use a whip antenna, which is a single wire antenna, same as your ute. We won't use the TV style antenna, which then you can't repeat off, because I'm talking to you and not to you, and therefore you have no chance of repeating via me to him. We have done it in the past, funny enough, just for cellular. So we talk to the tower, which breaks Telstra's rules, but they just live with it because they don't want to argue. Somebody's fixed their problem. So that's the choice here, and it's a little bit of an arbitrary one, but it is important if you're thinking about it and you've got coverage, not great coverage, we can put a directional antenna to the nearest tower, which, depending on where you live, would be, I suspect, here. I haven't actually looked at that. I should have seen the local towers. And that speaks to repeaters, so we would always use an omnidirectional antenna, so you can talk on behalf of anyone in a 360-degree angle. I spoke about foliage and coverage up here. So bad, so dry. There's not much of that. But anyway, you've got to think about that. If there's tree lines, but at UHF, it just blasts through. There's no issue there. That's why I said this is more of a general case. And antennas above ground, I'll cover a case we did in the Pilbara, where there was a farmstead in a river valley area, and they wanted to monitor a couple of tanks quite far away, 30 kilometers away. And there's no ways we could get the radio signal out of the valley to them, even trying to repeat, and I spent quite a bit of time doing it, and that's what I do a lot of is radio survey work. We calculate if it'll work before we even arrive there. And we ended up talking to the farmer, and he said, well, there's a hill next door, but it's my neighbor's hill, and I'll go and talk to him. And I think they ended up helicoptering at a cost, sure, because it wasn't a tank. It was just one of those units stuck on a concrete base on top of this hill. And of course, then the neighbor loved it because he ended up having coverage of his farm. So I think he ended up buying equipment, Phil, I think, yep. So they ended up with one repeater shared amongst, I don't know, eventually maybe 10 or 15 units. So that made sense. Otherwise, it was not going to work, and you would have to have satellites. And with satellites currently, unless you're going to pay a lot of money, you lose the option of cameras. Most satellite systems cannot handle camera data because it's a lot. So that's that bit there. So height above ground, and I underline that because whenever I'm driving, because I've been doing this for a lot of years, I look around, oh, there's a nice hill, there's a nice hill. I used to hang glide as well. When I see a nice cloud, I say, oh, I'd like to fly into that cloud. But it's in my DNA to look for the hills because it's an RF thing. You get up as high as possible. Right, so when we get, this is James Clark's farm called Pineda, up about 120 kilometers north of here. I'll show you that. So we are here, and that's the farm, and the extent of the farm from the furthest most units is just a little bit smaller than Cubby, which is 43 kilometers long. And I mentioned it earlier, they run a UHF system, but a low-power UHF system which has multiple hops. But the bottom line is we were able to, over 2 repeats, we were able to cover that, except for the terrain. So I just want to go back to that one again. So what James did, he went out to all his watering points and got GPS locations, just your phone app, and you key it in, or you send it to us in an Excel spreadsheet, or Google Earth has an option of KMZ or KML files. Most people know how to use that. If you don't, just write it down, and the name of the tank, often very weird names, like my niece's auntie, his uncle, and old oil bore, which I suggest there might have been a bit of prospecting going on there. Anyway, that's what we were given, but this doesn't really show you elevation. You can move Google Earth, and this is the Pro version, which gives you better resolution, which I use and pay for. You can move it around, yeah, but it doesn't really tell you a lot. But the next picture, we take that information and we key it into, not that one, that's just an idea of where it is, up in the southern Flinders, or mid-southern Flinders, I think. We take that information after we have asked James as well to tell us where his cellular might be working on the farm. So that's that group up there. Go back to it. That group. Sorry, I shouldn't have had that slide in the middle. There's another group-ish here, and the reason why that's singled out, because there's no coverage there, and we couldn't easily solve it, because this is in a ravine. If you look at the next slide, which I'll go to, so essentially there's 3 groups, and one might need it to be a standalone. But nobody besides James has driven there. This is all done, calculated. And that's a Telstra map, which is publicly available, which you can go in and we modify it a little bit. A phone would not have an external antenna. It would generally be 4G. And 4G, that 4G is completely useless. It'll work around town, but not much further. So you drive out of town and it flips over to 3G, and then later on it'll go to that one, 4GX. Which is I'm working on with a number of vendors. External antenna gives us that 0 to 1 bar, takes us to 1 to 2 bars, just having an external antenna on these units, compared to a phone, which is a 0 gain antenna. And we print them out. And that shows us the speeds we could likely get, and areas that just won't work, or calculated not to work. Nobody's driven out there and tested this like Google road map thingy. This is just calculated, and we've often proved them wrong. So I think they might end up using our data to actually show what really works. So that's just a comment thing. I took a standard map. I knew where they were, and then we enter that data. It's automatically imported into some very fancy software, which is radio mapping software. And this shows elevation with different colors, like an isotropic map, where you can actually see, and this is normally there. I just took it away. It shows 400 meters above sea level. So this is quite high. It's Mount Lofty-ish, actually. And anyway, these don't look very onerous because this is a zoomed out view. If I zoomed right in there, that would look like a precipice, a cliff. And there's our little guy which we battled to get, which we thought we were going to get. And the cellular coverage didn't originally look like it was going to work there, but it did. We ended up putting one of those little units in. But clearly, the 40 odd Ks to there with a range of a UHF about 20 odd Ks under good conditions, we weren't going to make that. So we decided to make that group a separate group, like a network, that group is a network and that group is a network. Because also we would like to also understand that if you have a gateway, which is the unit that's connected to cellular, and it for some reason goes down or battery goes out or something goes wrong, you lose all of the units talking to it. So it's a redundancy thing that I was schooled in and studied with the Army. You would have lowest redundancy possible. So in other words, if you're going to repeat once or twice, not more, and have a few units that you're going to lose as possible. So for example, you would lose 3 there plus that unit if that went out. But here you would lose a lot more, and there's repeats. But anyway, you've got to keep costs down, so you can't just arbitrarily have repeaters. So that software is a lot more than you're seeing. It outputs each link, and this is a bit of the low-level engineering, but it goes to show that we actually put a lot of effort into doing this. It's not just arbitrary, and it doesn't cost a lot. In terms of the cost of the equipment, it's in the hundreds compared to a few thousand for telemetry. But this radio mapping software is entered. We're using a 5-watt radio, Observant UHF, and it shows to us that even though we've got a big mountain in the road, and this is, that's something, Olden Hill tank to the Matthews tank. If I go back to that, it's here. There we go. It's one of those links. I can't see it. I've got no glasses on. In fact, I'm just seeing blurs all over the place. But it shows you how UHF works. There's no line of sight. There's no chance you could shine a laser from there to there, even though this is on a nice hill. And we've elevated it to, where's the elevation? There it is, 3.5 meters. We typically put those on a tank on an additional meter just to get the gateways as high as possible. And all the others are typically 2.5 meters, 2.2 height of a tank. So this is not, you don't have to take special infrastructure and put poles in the ground, although if you want cameras in different places, you have to. But the bottom line is it's really quick in install. And we couldn't have done that other picture with the orange things in a number of years if it wasn't easy to install. So that calculation is done by the software, and it gives us a number to say our signal strength is the right word, is -88, and our target is -95, even though the radios will work to -125. So we've got huge margin built into the system for storms or for very hot weather, funny enough. That's also when radios lose their performance. They call it diurnal fluctuation. When it gets really hot, they lose performance. It's a physical property of air, radio waves moving through the air, and the radio getting hotter as well. But anyway, that works. So even though it looks like it shouldn't work, we say that's a good link, and we go through all of them. So there's a whole big spreadsheet, which goes back to Phil, to say, before any equipment is chosen or anything, we've done all the calculations. So it's not just a run out there and wander around and think it's going to work. And we didn't do this initially, but we do it now because that saves us running around and finding it's not going to work after the customers bought the kit. So that's a lot of what I do for this enterprise. So, okay, so that's that. Pineda farm, I just want to go to one where I mentioned earlier out at the Pilbara, Glen Forest Station. I think Phil's going to go live onto this one. Very dangerous going live, but he's brave. Where there is no cellular connection here at all. And I didn't mention that earlier because it's the kind of thing that doesn't often happen. Well, probably not so much in this country, but out there it does. So this has a Skymaster or some other satellite system, which cost a lot of money. They're coming down in price, and those things are starting to change very quickly. But that's all they had. They had a domestic Wi-Fi satellite connection. So they had a unit that could talk back end. So that replaced the cellular. And in fact, is that product still available, the X1? It is.
We actually use that C3 now as a base station.
Okay, so it's a base station now. Okay. So this was done a year or so ago, I know. And it was me as a challenge to say, there's my watering points over a big country. 34 kilometers, one of these links. No ways, and the software actually tells you, anywhere it's red and yellow, it says yellow's a bit dodgy, red, no chance. You can't park your trough on the side of a cliff here, it's not going to work. But that's a long link. I mean, you think of your farm 34 k's away, think of your blocks now, that's a big chunk. So that's where we went and back and forth to the farmer where he said, well, there's a nice house. We actually sent him this picture, and he said, well, there's a nice house spot there, but I don't own the land. I said, well, if you give me that, because I did the calculations before, and you get access to that, I'll solve your problem. And he did that. Spoke to the neighbor. They ended up helicoptering a thing on a concrete block up there. So they have to be robust to be able to handle that. I don't think they could even land. I think it was these guys fly helicopters, they land anywhere, but So we allocated a repeater, and bang, and Phil's going to go live on that one later. Literally, we can go and take a photograph of that now, and we'll see it in a few minutes. So it's not a...
Just flip back if you don't mind, I'll just want to interrupt. So all of these are water points, and they've each got one of those on a water point.
Yep.
If we weren't able to reach this one directly, then that one could relay back via that one and back to the house.
Yep.
So they're not only a logger, they also act as their own repeater.
Yep.
So we can go in hops, and we'll log into Mount Riddick later at Alice Springs.
Yes.
It's about 80k spread we've got with a couple of hops up to a mountain, and just wanted to...
Actually, that is a good point, and I did skip over that. I mentioned it earlier and thought it was done and dusted. In fact, it didn't not work. Double negative. Only one link worked. See that green one? Which said, if I had chosen it, this is like way beyond the radio's capability. One link would have worked. We could have chosen to do that, but we thought, well, if we do that, then we have full coverage anyway with one repeater. And because that one wouldn't have reached that one. I tried all the options. I didn't want to bore you with all of the calculations. A couple of hours to try and work out that if we'd used that as a repeater, so we chose that one there as our... You remember this? We did it after a few days. Anyway, the very chuffed farmer. But yeah, I'll just go back to this one here. There's a good example of Pineda, which I should have covered, where there's a gateway running out to multiple units, and we had to repeat to get over a ridge line. I wish this could have zoomed in, but the first presentation I did, I realized we were way short, so I'm actually doing more detail now. But there's a good example. It had to repeat. And I could show all those links where that wouldn't have worked from there to there, but it does go via a repeater. So, and you can, Simon Holmes-Court said to me when I asked him, as he designed this thing originally, and I was a young RF engineer. Well, actually, I'm twice his age, but I think I'm young. He said 128 hops, and we're never going to do that, because you'd cover right across Australia, I think. 6,600 kilometres times 30 kilometres, 120, a lot. You cover into Perth, I think, from here, something like that, a long way. Never going to do it. So the bottom line is we typically do one or two repeats. And under ideal conditions at 20 odd kilometres, it's 40k reach, and then by then you're into cell coverage. The trick here is to be able to get into cell coverage, and then you've solved the issue. So I'll go to where I was. There we go. So that now, I think, has been populated by some neighbour units talking off there. But this, we've only accessed the Glenforrie data here. And if the other guy saw it, he would probably only see that unit and his units. So it separates that, even though they're sharing one repeater. Then we go down to a project that we've been working on, and for years and years, government projects take a long time to get going, as you would understand. It's a water buyback scheme where it's based up, it's called Gunn Bar Water, and it's north of Hay. Hay is, those two roads join, Hay is down here. Very large scheme of many hundreds and hundreds of units going out there, where 90% of their water that was in a ditch from the Murrumbidgee, low quality water, outfall from the vineyards with all sorts of contaminants in it, was being, sheep were being watered off that out of ground tanks, dams, and the association was set up to sell 93% of that water, or 90% I think is the right thing, back. So that's not water coming out of the Murrumbidgee for the, say, 50 odd million. It sounds a trivial number, but that's a whole lot of water saving, and it's persistent going forward. So they put in filters, proper or better filtering, well, filtering for a start, out of the Murrumbidgee. The water, I think, has moved to a higher security level because it's now pumped. There's infrastructure, and these lines run up the main roads, and then as the pipelines are getting to the farm gates and the metering goes on, we start installing these kits and the on-farm pipelines, and that one actually is drawn, those on-farm. I think the meter point was there. There it is, outlet point. There's the main road. Lots of units, and that, because it's such flat terrain and budget constraints of a large project like this, you get pressured for price. We went with a 900 megahertz system, which per unit is cheaper, doesn't have the range. I think we're looking at about a 9 kilometre. I know because we had a camera running there prior to the tendering process. We ran a system out there anyway, just to prove we could actually do it to ourselves. And that was a camera stuck up over a dam and on a fence line, taking pictures every 15 minutes, and so at least we could show that it was working. So that's a single gateway being able to talk. Oh, and another part is on 900 megahertz, it's far more bandwidth. So, you get on a phone and you've got a bad connection, you can't load your signals or your Netflix or whatever. That's a bandwidth constraint. 900 megahertz has got very wide bandwidth, and 2.4 megs of Wi-Fi is even much wider. So you can handle far greater volume of data through it, even though we don't really care. We just send, the worst we send is camera data, which is a fair amount of chunk of data. The 5 watt radios only have a very low bandwidth, but we don't care. We take a picture every 4 hours currently, and that's fine. If you want to take one straight away, you're welcome to do it. Just go and take it. If you think something's wrong, or somebody drove past and said something's weird, or you see your tank level dropping, you want to see what's going on, is it flooded out, which is a case of a valve is stuck, go and take a photo. But that scheme there, this is the first part of it. There's many more. I should have maybe taken a picture of all of it, but anyway. And that one, so that's currently a project that will go on for another 6 months or thereabouts. A large amount of units. That's just showing a small farm, actually. So the outcome of all of the previous talk is Pineda, and I took this 2 days ago before the narrow court session, where the client set this up. We didn't do any installs here. The client set this up himself, and he's done some really sneaky things, really clever things. There's an old concrete tank, the little old valve in it, and he's positioned the camera cleverly so you can see the trough and the top of the water. On the others, he's got the floats on them, clearly empty, no animals around. In fact, I think it's full again now. That was just a little while ago. So that was 2 days ago. That's when I physically captured it. And James would normally be here, but he gave us permission to use this. There's a bush chook there, and that trough there, resolution on our phone is much better than this projector. And there's a whole lot of algae, and that trough needs to be cleaned, big time, soon, because it's floating on the surface and like lilies there. But the rest of it, I think when they first installed, they had a valve go wrong here, and that's a solar bore. And it drained these, and there were animals, and everything was trying to lick the last few drops out of there a few weeks later. And I think the comment is it saved him a whole pile of money, which it does. Importantly, and I haven't covered it, and Phil is going to cover it, and I don't want to tread on his toes, is you get alerts. You can set alerts for almost anything, not for pictures, because there's not much you can see except a burglar trying to steal something, which they don't have motion or anything like that. They're not designed as a Wi-Fi camera that can see guys stealing diesel out of your shed. But alerts for flow and pressure, you can appreciate, you can set it, and I'll show you a picture now, where if it gets below 50%, you want to know about it, because it's a pressurized system. It should stay at 80 or 100, if that's what it is. But if it gets to 25, you can set 2 alert levels, both on the high and the low. And if it gets to 50, you think, oh, maybe the pump isn't catching up, especially on a solar bore situation. You get another alert when 25. Then you've got to take a water cart out there or do something. So I think the value in this thing, after having done so many, is the fact that you get an early warning, especially if you're not at your block. And we've had cases up at Pineda area, not actually that far from here. We could drive there closer than back to Adelaide nearly, where we put in a site where I think the owner's son got married, and he's now living in Nurupta, or spending a lot of time, as the wife is from Nurupta. He logs in and gets a guy from town to go and do, because I think the round trip there would be about 180 k's to all the troughs. So he just goes and acts on things that need to be acted on. And it's dry country up there now. When we installed that, the grass was, you couldn't see the sheep. And now, of course, nothing. But anyway, it's another story. So what we see at James's site here, mainly he decided on cameras. That's what he thought his highest value was. But you don't get an alert from a camera. So if you're going to do a level sensor, which is what I've spoken about earlier, you'd stick that on a pressurized line at the end. Think about it. If there's a pressurized line and your valves aren't messed up, they're all going to be full. But the end one is the one you need to know about, the end of the line. So I'm not sure if that is done like that, but I think he's only got 3. Phil's going to go live 3 level sensors, which you do get alerts on. But if you're clever about it, you can. A camera is more expensive than that, so he's chosen the Rolls-Royce option, but he loves it. And he's got pages of this. This is just a snapshot of one screen. So that's Pineda. Another one, in terms of other sensors that the system can connect to, that's applicable to your industry, is definitely pressure and flow. More so in this case with flow. The talk we did at Narrow Court, Phil has been down. This particular client has got a leased block down in Mount Gambier, and I think that's 120 k's, something like that, up to Keith. And he doesn't want to go there. No, it's 200 and something kilometers, 220 I think it is. He doesn't want to go there every afternoon because the lady on the block is not there all the time, so he can't get things done, or at least he needs to know if he has to leave, get in his ute. And so that's a typical scenario, and I'm sure you've got scenarios up here where there's not necessarily lease blocks, but your farms are big enough to not want to drive to the end every day. So he has now chosen a different set of sensors, and that's live as of, now dare I say, 4:13 this morning, I think. I drove up this morning to get here. So typically he's got, these are all flow. He's got some tank level sensing, and I just zoomed in, and now that just shows you a quick overview. So if you can look at your phone, because you don't want to drill in too much detail, you look at it and say, well, that looks good, all the lines are straight, and there's no alarms, I haven't got any texts. But I drilled into this one, because I'm sure I wouldn't have got it, but he would have got a text, 25% it dipped to. This has only just been installed, so some of this data has only started 3 or 4 or 5 days ago, but that's an example of a local one that I know is now live and accumulating data as we go. So there's flow. There's also, he put a couple of rain gauges. I didn't know that until I looked this morning. So that must have been the Mount Gambier ones since install, and that probably is the Keith one. So that's the accumulated rainfall since install this year, so total this year. And I won't go through all the detail. You can say this week, yesterday, tomorrow, all of that. The options there are obvious that you can do. So that's pretty useful just to get an idea of what rainfall. So that's not Bureau of Metrology, that's on your farm. Well, that's actually usually on your tank. Literally, that's the unit with the spikes up there. It's got a little tipper rain gauge, which are proven to be really reliable compared to the electronic ones I've worked with, and I'm an electronic engineer. I prefer that one. It's a little switch that tips out 5 mils every time it does this, and counts 5 mil for that area and works out how much rain. So those are 0.2 millimeter accurate, so they're really good. And because they've got a little chrome thing, you should look at it if you get a chance. I think Phil will open it. I hate those things normally because they fill up with bird crap, and you know they become sludgy and they just misreport. But they've chromed the plastic and it just cleans itself. It's such a clever idea. And the other much more expensive ones don't, and you know they crudge up. So that's the Gommers, flow and level. And once again, I think this is about a third of what he has out there. And he's got flow and pipelines going out in different directions. So that's the end of that one. Yeah, I thought I did another one. Anyway, I didn't do another one. Showing him with a header tank and flow going 2 different directions. But Phil will cover that off now. Any questions?